right. ඉතින් මම හිතනවා ඔයගොල්ලෝ දැන් මේ වෙද්දී අපේ කලින් වීඩියෝස් ටික බලලා ඇත්තේ. එතකොට ඒකෙදි මීට කලින් වීඩියෝ එකේදී ඔයගොල්ලන්ට ප්‍රශ්න ඩිස්කෂන් එකක් ගෙනාවා. විශේෂයෙන්ම 19 20 මේ ලාස්ට් ඉයර් පේපර් එක. ලාස්ට් ඉයර් පේපර් එකේ මෙන්න මේ ඩිස්කෂන් එක ගෙනාවා. එතකොට මේ වෙද්දී ඔයගොල්ලෝ මේ පාර්ට් 2 ඕගනික් එකත් පාර්ට් 1 අපේ කලින්ම මේ 2023 ළමයින්ට මුලින්ම කරපු වීඩියෝ එක. It means the first video for the 23 students. With the organic part, I discussed about how to identify the stereo centers and RS configuration. And with this one, with more organic part, I introduced you the some sort of summary I discussed kala. And after that, with the cat 1 discussion, I discussed the last year paper. It was a home assignment. The home assignment එකක් තමයි තිබ්බේ. I discussed the questions of that. Then you might remember E2 reaction we also discussed. The E2 and anti-periplanar arrangement things we have discussed. Then finally we realized, you realized this paper, this year paper, mostly it will be MCQ and structured paper, like 14, 15, 15, 16, 16, 18, then 17, 18 paper. ඒ වගේ paper එකක් තමයි MCQ and structures එන්නේ. So due to that, I discussed to, so I thought it will be a benefit for you to discuss some MCQ questions. So this is 2014-15 paper. As you can see, it's a 1 hour paper. The paper, like you will get this sort of paper in January 1st morning, right, with the new year. Okay, then let's discuss this part. First, they are asking how many stereoisomers are possible for following compound. Yeah, so in questions like this, actually this sort of question must be very easy for you. නේද? මේ වගේ ප්‍රශ්න આવුත් නම් ඕගොල්ලන්ට අනිවාර්යෙන් ගොඩක් ලේසි වෙන්න ඕනේ. මොකද මේ වගේ ප්‍රශ්න කියලා කියන්නේ අනිවාර්යෙන් පුළුවන් වෙන්න ඕනේ. Okay, how we are going to do this question? So this is the molecule, the given molecule. Okay, you will see the double bond is there. You might remember double bond mean, but all the double bonds are not stereo centers. The same double bonds stereo centers නෙමෙයි. So you have to figure it out. So in this case, you will see this is a stereo center. So this is the hydrogen is there, another hydrogen is there. So you see this is actually trans configuration, or in the EZ term, we can categorize this as same side says, but this is different side hydrogens. So it is E configuration, but it doesn't matter here. Yeah, somehow you have to identify this part as a stereo center. Like a stereo center එකක් කියලා අනිවාර්යෙන් identify කරගන්න ඕනේ. So one stereo center, and what about this one is another stereo center. You have to realize hidden hydrogen also there. Always the hidden hydrogen is some sort of a surprise for you. මේ වගේ අර hidden hydrogen එකක් අනිවාර්යෙන් තියෙන්න ඕනේ. ඒක අනිවාර්යෙන් බලන්න. So එතකොට එතන hydrogen එකත් එක්ක you will see make up when we divide into 4 groups, hydrogen and this part and this whole part and this CH3 part. So 4 different groups attach carbon. So this is a one stereo center. This is another stereo center. So totally 2 stereo centers are there. But this carbon is not stereo center because of, you might see, you have to see same hydrogens. 2 hydrogen groups are attached to that group. In the 2n, so 2 into 2, 4. So what will be the answer? The third one is your answer. Hari, I think very easy question. The Meva question. And actually, එකක් කියලා ඇත්තටම මෙහෙම බැලුවොත් ඕගොල්ලෝ හරිද නේද? ඇත්තටම මේකේ you have to realize there is another stereo center. නේද? මේකේ තවත් stereo center එකක් තියෙනවා. ඒ stereo center එක තමයි මොකක්ද? මෙන්න මේ stereo center එක. මෙන්න මේක. Most of them did not realize this one, it is also another stereo center. Say, so there is another hydrogen. So 1, 2, and here also you have to divide like this. So it's another group and this is another group. So 3 stereo centers are there. Ne? This is a 1 and this one is another one, this point and this point. So 3 stereo isomers. So 3 to the power n to the power 3, 2 into 2 into 2, it will be 8. So that's how answer is coming for the fourth one. Fourth one is our answer. So I think you just realized most of the students, I just remember few of them, they asked about this question. They didn't realize this part as a stereo center. Think. ඉතාම ලේසි කොටසක් හරියටම කරගන්න පුළුවන්. Right. What about the next question? So first one is okay. The second one, which of the following compounds show optical activity? You know, optical activity means to show the optical activity, they have to indicate stereo center. Stereo centers, there can be stereo centers there, and but the thing is, you might remember mesoisomers we cannot consider as stereo isomers. මේකත් ඔයගලන්ට මතක ඇති mesoisomers අපිට consider කරන්න බැහැ කියන කතාව. Right. එතකොට අපි බලමු එහෙනම් මොකද වෙන්නේ කියලා. මේකේ we can okay, the first one. First one, what is your idea? First one, 4 different groups. Yes, we can see clearly 4 different groups. So it means this one indicate the one stereo center is there. This is the stereo center. So it is showing optical activity, right? So it is okay. What about this one? 4 different groups also there. It's not the mesoisomer. It's not the symmetrical molecule. In this way is not the symmetrical. May with here symmetrical na. So I think we can easily categorize the second one also a stereo center. Second එකත් stereo center එකක් වගේ කියලා optical activity වගේ කියලා you can consider, but we'll see. And what about the third one? The third one is a quite tricky one, but it will be very easy one. It will be very easy for you if you are doing the correct way. And you have to consider 2 parts, and this part you have to divide to 2 groups, and you have to identify if these 2 parts, after you divide with the middle line, you have to consider these 2 parts, if whether it is same or not, equal or not. So it's not equal, these 2 is also not equal. This is NO2, this is CH3, the carboxylic group. So we can consider C also, B also optical active, C also optical active. But this one, you might see, you have to see the triple bond case. We cannot consider it as stereoisomer because of this part. මෙන්න මෙතන සමාන parts දෙකක් තියෙන්නේ, same 2 bromines. If this bromine is another one, it's like hydrogen, so this one also we can consider as stereoisomer. So, but unfortunately, it's just bromine, so we cannot consider them as stereoisomer. So this is not. So A, B, they have the answers A, B, AC, AC, okay, but the thing is D. So we cannot consider this one because of D is not the stereoisomer. And the another one, right? In this case, it seems these 3 structures, ABC, we can get the optical active, we can get as optical active. Only the third one is the exception. But the thing is, you will see all these things are correct. A, B, first one, second one, fourth one, and fifth one. So in that case, we have to choose something special. We have to consider some special thing here. In the middle one, but this structure is stereo isomer, but there is a thing. Actually, this one, I think we can draw a stereo isomer like this for this one. Okay? So it is mesoisomer. I thought that's why they just avoid this one for the answer, and they just get the answer as A and C. But this part, But thing is, you have to find the most suitable answer in this case. So I think most suitable answer is the second one, A and C, because of this part. One isomer is there with the stereoisomer. It means mesoisomer is there. One mesoisomer is also there. So that's why I think it's better to consider A and C as your final answer, right? So the second one is the answer, right? I think you got the point, right? Okay, the third one, the third question, they have mentioned three groups here. Right. So in this case, with the third question, we can see a few types of questions are there. Okay. Structure A and B represent pair of enantiomers. Structure A and B. So these two are the structures. As we can see, this is shaded one and bold one. So it should be, and this one is bold, this one is shaded, this one is bold, this one is shaded. Yes, see, all the shadeds in the A structure are bold in B structure. All the shaded structure, all the bold structure are shaded in the second structure. මේ සේරම කඩේරි වලින් තියෙනවා, මේකේ තදේරි වලින් තියෙනවා, තදේරි වලින් තියෙනවා, කඩේරි වලින් තියෙනවා. So yes, it must be correct. A and B are stereoisomers, pair of stereoisomers. So first one is correct. The first one is correct. There is no argument about that. I think you realize that part. So B and C represent a pair of enantiomers. B and C. So we have to compare these two. No, this one, because of C here, the dark one remain dark one. It's remain dark one, so we cannot consider those as stereo isomers. So they are not stereoisomers, enantiomers. Enantiomers. Actually, we cannot consider those as enantiomers. That's why enantiomers must be like that, or otherwise it should be mirror image. Otherwise, mirror image also can be there, but unfortunately, these two are not mirror images. B and C are not mirror images. A, B mirror image, it's fine. Right, okay. Then what about C? A and C represent diastereomers. Okay, A and C, yeah, shaded one, dark, the bold one, become here the shaded one. Okay, here, shaded one, and bold one. But the thing is, it's the other way around. This part is other way around. So A and C is also diastereomers. මේක තියෙන අනිත් පැත්තට දැන් අර mirror image එක වගේ තමයි මේ දෙන්න තියෙන්නේ. So actually the one thing is you have to see here the shape. The molecular skeleton is same. AB skeleton remains same with the enantiomers. The skeleton එක සමාන වෙන්න ඕනේ, but shaded one should be dark one. Dark one must be, actually not should be, must be. Shaded one must be dark one must be shaded one, but the same skeleton, same arrangement, same pattern should be there. Otherwise, we can draw the mirror images. But the thing is, mirror images not the same pattern is there. Mirror image is coming like this. If you are going to draw the mirror image of this one, must be like this. Right. If you are going to draw the mirror image, it must be like that. It should be like this. So these two also enantiomers. This is the one way of representing enantiomers. Otherwise, you can draw the same pattern, but all the Shaded one should be bold one should be shaded one, right? So this is also another representative way. Right? Actually, with the first one, A and B represent the pair of enantiomers. They have shown these two structures as this way. මේ විදිහට තමයි පෙන්නලා තිබ්බේ. So it's also enantiomer. Otherwise, they can draw the mirror image too. හරි. So that's why the A and C appears. You will see they have mentioned it like the mirror image. Mirror image shape එක වගේ තමයි ඒක පෙන්නලා තියෙන්නේ. But the thing is, okay, this part is okay for the mirror image, but this one, see, this shaded one here become bold one. So that's why it's diastereomers. පේනවද? දැන් මම හිතන්නේ ඔයගලන්ට පේන්නේ නැති එතන ඒ මම කිව්ව දේ. enantiomers අඳින ක්‍රම කිහිපයක් තියෙනවා. එකක් තමයි ඒ pattern එකටම අඳින්න පුළුවන්. හැබැයි එහෙම ඇඳුත් මොකද කරන්න ඕනේ? අර කඩයිරි ටික තදයිරි කරන්න ඕනේ. තදයිරි ටික කඩයිරි කරන්න ඕනේ. Right? The other way, the අනිත් පැත්ත තමයි එහෙම නැත්නම් mirror image එක වගේ අඳින්න ඕනේ. එතකොට කඩේරි සේරම කඩේරිමයි, තදේරි සේරම කඩේරිමයි, but it should be like this නේ. මෙහෙම නම් මෙහෙම. මෙන්න මේ වගේ mirror image pattern එක තියෙන්න ඕනේ. මේ pattern එකට තිබිලා හරියන්නේ නැහැ. දැන් මෙතන molecules ටික AB තියෙන්නේ මේ pattern එකට. C එක මේ වගේ පෙන්නලා තියෙනවා. But you will see දැන් එහෙම පෙන්නුවොත් mirror image වගේ පෙන්නුවොත් all the නේද? කඩේරි තදේරි වෙන්නත් බෑ. ඒ විදිහටම තියෙන්න ඕනේ. අර පේන mirror image එකක් වගේ තමයි පේන්න ඕනේ. මම හිතන්නේ මේ point එක පැහැදිලි ඇති කියලා. මොකද කලින් videos වලත් ඕක එක එක අවස්ථාවලදී අපි පැහැදිලි කළා. එතකොට ඔයගොල්ලන්ට පේනවා ඇති A and C තමයි මෙතන හරි. එතකොට A and C කියලා කියන්නේ එතන මොකද්ද අපේ answer එක? first වෙනි එකනේ. The fifth one is our answer for the third one. Right. Okay, the fourth one එකේ වුණ ප්‍රශ්නයක් අහනවා. Alpha D value of A is minus 49. Minus 49 කියනවා. Select the wrong statement කියලා තියෙනවා. The alpha D, you might remember ඔයගොල්ලෝ අනිවාර්යෙන් මතක ඇති නේද මේ අර enantiomers වල තියෙන වෙනස්කම්. enantiomers වල තියෙන differences ගැන අපි discuss කළා. එතකොට තමයි මේ point එක අපිට ආවේ. නේද? The only difference we can see is the rotation of polarized light නේ. එතකොට A එක දැන් one enantiomer if it is minus 49, the other one must be plus 49. So the first one is correct, okay? But they didn't mention. I think I know the B is it's. I think this part is connected to the previous part. නේද? අපේ කලින් part එකට මේක සම්බන්ධයි. A B actually that sort of questions also are there. You have to be aware with that. And the question A and 4 are based on the following structures. So that's why if you cannot identify correctly what are the enantiomers and what are the diastereomers, you will just lost. So the first එක correct. Then actually they are asking about the wrong statement. So first one is correct. So there must be 4 correct statements and one will be wrong. We'll see what is that. Right. The second one, if the one-to-one mixture of A and C is 0. One-to-one mixture of A and C 0. That may make a 0 when a one-to-one mixture mean same molarity mixture එකක්. But racemic mixture කියන තත්ත්වයට આવත්, you know, if we can consider those as racemic mixture, one-to-one mixture must be there, and the other thing is both must be enantiomers නේද? Both must be enantiomers. Enantiomers නැති ඒවා අපිට consider කරන්න බෑ 0 කියලා. Then if instead of C, if there is B, this is correct. But unfortunately they have mentioned C, so this is the wrong. This is the wrong one. I think අනිත් statement බලන්න ඕනෙත් නෑ. We no need to consider the other thing. Okay, but just get a rough idea. Third one, alpha D value of one-to-one mixture of A and B is 0. Yes, correct. That's what we already discussed with the second statement. The AB because of their enantiomers. So one-to-one mixture must be 0. C cannot predict the following available data. Value of C, yes, we cannot predict. It is another diastereomer. We cannot predict the value. 1-to-1 mixture of B and C cannot predict the available data. Yes, also we cannot see. We cannot predict. හරි මෙතනදී මම just කියන්නම් මෙතන 1-to-1 නැතුව mixture එක එකක් වැඩි වුණොත් එහෙම like 2-to-1 or like 3-to-1 or like 3-to-2 වුණොත් එහෙම what will happen? Just imagine අපි හිතමු 3 එක නම් positive මේක නම් positive මේක නම් negative නේද? If this molar percentage is high, it means our value remains something positive. තේරුණාද කිව්වද? දැන් අපි හිතමුකෝ මෙතන ඒගොල්ලෝ කියනවානේ A තමයි කියනවා නෙගටිව් එක, B තමයි කියනවා පොසිටිව් එක. ඒකට මෙන්න මේ විදිහට නෙන්නේ. මෙහෙම આવොත් එහෙම දැන් 2-to-1, 3-to-1, 2-to-3 වගේ આવොත් එහෙම මේ රේෂියෝ එක වැඩි නම් B එකේ probably it will remain something positive but less than 49 නේ 49 වලට අඩු යනවා නේ plus 23 or plus 30 වගේ value එක remain වෙලා තියෙයි ඉන්නෝනේ plus somehow 31 or somehow less than 49 හරි 49 වලට වඩා අඩුවෙන් මම හිතනවා මේ point එක ඔයගලන්ට පැහැදිලි වෙන්න ඇති කියලා ඒ හින්දා ඔයගලන්ට මම මේ ගැන වැඩිපුර විස්තර කියන්න යන්නේ නැහැ I think you got the point. හරි මම හිතනවා point එක ඔයගොල්ලෝ ගන්න ඇති කියලා. Right. So with the next question, they are asking the same thing here. E is a diastereomer of D. E is a diastereomer of D. They are saying like that. E is the diastereomer of E. Okay. Both D and E gave the same ketone on oxidation. Both D and E gave the same oxidation, ketone in the oxidation. Right. So same ketone. So you have to realize first of all, what is the oxidation part of this compound? This is the one. මේක තමයි oxidize වෙන්න පුළුවන් එකම part එක මෙතනදී අපිට පේන විදියටනේ. මේක තියෙන එක. So diastereomer එකක් වෙන්න ඕනලු but both D and E give same ketone on oxidation. එහෙනම් මොකද වෙන්න ඕනේ මේ part එක අපිට ප්‍රශ්නයක් නැහැ because of we know this is sp2 hybridization. So initially it is sp3 doesn't matter. මොකද මෙතන we can see in this OH is below the plane. Below the plane තියෙන්නේ. So we can choose okay what about this one? It is above the plane. So with the oxidation it doesn't matter. Both gives this one. sp2 means same structure. So this is below the plane, this is below the plane. So this must be our answer. This one, this is okay, this is fine. It doesn't matter which the OH part is below the plane or above the plane. It doesn't matter for this one. Only matter is the other group. So this is above the plane. So it will not get the same ketone. It will be another diastereomer. So in this part, it is other way around. See, this means they are what? Mirror images. Mirror images. So mirror images mean they are enantiomers. They are enantiomers. So it's not an enantiomer. They are asking about diastereomer. Somehow they will not give the same structure also. What about the fourth one? Fourth one is okay. Fourth one is also a diastereomer, but see, no. Fourth one is. What is your idea about the fourth one actually? It's not. Yeah, it's also diastereomer. OH, yes, and this one diastereomer, but yes, it's diastereomer, but it doesn't give the same structure. It doesn't give the same structure, so we cannot consider it also as a answer. But about the fourth one, yeah, fourth one also wrong. It's the same structure. It means OH, it will be fine. කොහොමත් OH එක double bond O වෙනවා, but this is the shaded one. This is the bold one. So we cannot consider that as our answer. Right. Okay. Right. හරි නේද point එක. Fourth එක ගැන තව පොඩ්ඩක් අපි බැලුවොත් එහෙම කියන්නේ මොකද now if we convert the fourth one the other way OH become shaded and this become dark. So yes, it seems okay. Right. Okay, somehow we have the correct Yeah, here, okay, the thing is, what is it? C and D. What is the connection between C and D? See, what's the connection in between these two? The same structure, ne? Same structure actually. Same structure. Same structure in the mecambene. So same ketone, it will give the same ketone. Same ketone, but this is the same structure. So they are not diastereomers. So we cannot get this one also. So what will be our answer is the fifth one. And for the first one is the answer. In my first take up a answer. That's the way. Right? Okay, I think you got the idea. Right, okay. Then the sixth question is coming from, what is it? Select the correct statement regarding the following organic solvents. Okay. Acetic acids. Just thing is they have given the structure. Yeah. Okay. If I just ask about whether acetic acid can form hydrogen bonds, what will be your answer? මම අහුවොත් එහෙම මේ acetic acid වලට hydrogen බන්ධන හදන්න පුළුවන්ද කියලා මොකක්ද ඔයගලගේ answer එක? Yes, it can. It can. It can form acidic hydrogen bonds because of you have to remember for the hydrogen bonds, the bond must be like this. This at least the hydrogen must be polarized with oxygen, nitrogen, and fluorine, and after that it should attract with oxygen or nitrogen or fluorine. But this one come from the another molecule. Right? එහෙම තමයි වෙන්න ඕනේ. මේකෙන් polarize වෙන්න ඕනේ මේ තුන් දෙනාගෙන් එක්කෙනෙක් කියන්නේ the intermolecular interaction must be in between this molecule and another molecule. මේ තව molecule එකක් එක්ක තමයි මේ intermolecular interaction එක ඇති වෙන්න ඕනේ. That's the theory part. Right. So acetic acid, acetonitrile, MECN, yes, then පේනවා MECN cannot have any polar. No, it's a polar molecule, but it cannot have hydrogen bonds. Okay, this one. How this part is there? In the main part you have to know it's like this. In the මේ වගේ arrangement එකද මේ වගේ දේවල් you have to know, right? So this part also cannot have any hydrogen bonds. Hydrogen bond, it means we cannot consider this an apotic. Apotic and potic, you might remember. Potic word is coming to describe the hydrogen bonds, right? Okay. So ethanol, okay, chloroform, okay, right. First of all, they're asking what? Correct statement, okay. Dimethyl fluoramide is non-polar potic solvent. Non-polar potic, no. Potic means it can form hydrogen bonds. No, we know it cannot. Okay? This one, it cannot, it doesn't show our requirement, yes. So non-polar is also wrong. It's a polar. It's some sort of polarity is there. So this is wrong. Chloroform and ethanol are polar potic solvents. Chloroform, oh my god. The chloroform is not that much polar, but somehow it's not protic. It cannot form hydrogen bonds, so it's not our answer. So it's also wrong. Right, okay. Acetic acid is polar apotic solvent. Acetic acid, yes, polar, not apotic, it's potic. It's potic solvent. It's potic solvent. You have to realize it's potic solvent. It's a potic solvent. Potic because it can form hydrogen bonds. They got hydrogen bonds හදන්න පුළුවන්. ඒ හින්දා ඒකත් එහෙම තමයි වෙන්නේ. So the fourth one, so this is also wrong. Acetonitrile, MECN is polar apotic solvent. Yeah, it's polar apotic. Yes, apotic means it cannot form hydrogen bonds. Correct, it cannot form. So fourth one is the correct one. We see the fifth one, dimethyl fluoramide is non-polar apotic. It's apotic. Apotic part is correct. Yes, it's apotic, but it's not non-polar. It's a polar. So that's why this part is wrong. So our answer is the fourth one is our answer. So the question number 7, it's coming from the mechanism part. Carbocation is more stable in ethanol than acetone. Yes, carbocation. You might remember carbocation formation is coming from, SN1 and SN2 reactions are there. SN1 and there's an, I can also, not O actually. Yeah, SN1, it's a two-step reaction. SN1 mean one-step reaction. The 1 and 2 is coming from according to the kinetics. And this part is the carbocation formation is there. Tertiary carbocation is more stable. Tritiya carbocation is stable. So, carbocation is more stable in more polar solvent. So, first one is correct actually. The ethanol is more polar than acetone. Ethanol is more polar than acetone. So, it's correct. SN2 reactions are favored. SN2 means single step reactions are favored in methanol than dimethyl sulfoxide. Okay, no, it means methanol is more polar than dimethyl sulfoxide, and SN2 only one step, only one transition state, and it's the some sort of neutral compound, neutral transition state comparatively this carbocation. So actually SN2 is more polar, more favored in DMSO, not methanol. So that's why it is correct. It means simply you can remember SN1 and E2 reactions are more favored in more polar solvents. Hari SN1 ඒවා තමයි polar ඒවට ගොඩක් favored වෙන්නේ. Favored කියන්නේ නේද? ඒවා ගොඩක් හොඳට reaction එක කරනවා කියන එක. So the third one, SN1 reactions always occur with rearrangement. SN1 not always rearrangement but sometimes with the carbocation, if the tertiary position can be there, the tertiary වෙන්න පුළුවන් නම් එක තැනකට සමහරට නේද secondary එකෙන් tertiary එකට rearrangement එකක් වෙන්න පුළුවන්, but not always නේද. E1 the same, E1 එකෙත් එහෙමම තමයි තියෙන්නේ. So ඒ හින්දා ඒකේ answer එක වෙන්නේ first answer එක. Right. So ඉතින් මම හිතනවා MCQ 7 MCQs මම ඔයගොල්ලොත් එක්ක discuss කළා. So it seems like the first part, it means stereo center part එක තමයි ඉතින් සාමාන්‍යයෙන් lazy part එක mechanism ගැන නම් මම වීඩියෝ එකක් කලින් ඇත්තම ඔයගලන්ට කලින් අවුරුදු වල ගෙනාව වීඩියෝස් ටික තමයි ඒකේ තිබ්බේ. මම ෆයිනල් වලට කලින් ඔයගලන්ට වීඩියෝස් ටිකක් ඒකේ දාන්නම් mechanism part එක ගැන තව වීඩියෝ ටිකක්. එහෙනම් ඔයගලන්ට සුබ පතනවා කට්ටියටම හොඳට එක්සෑම් කරන්න කියලා. ලස්සන්ටම එහෙනම් good luck guys. හරි මේ ටිකත් එක්ක හොඳට තව past papers බලන්න. kinetics ප්‍රශ්න තියෙන මේ stereo centers ප්‍රශ්න තියෙනවා, mechanism ප්‍රශ්න තියෙනවා, and also I think it's better to you have to remember about the graphs නේ, and also sololysis reactions කියලා set එකකුත් තියෙනවා. ඒ වගේම graphs තියෙනවා E1 E2 SN1 SN2 what happened when solvents මොකද වෙන්නේ, solvent stabilize කරන්නේ කොහොමද කියලා graphs ටික තියෙන. අනිවාර්යෙන් graphs ටිකත් ඔයගොල්ලෝ අනිවාර්යෙන් හොඳට බලා ගන්න කියන ගමන් එහෙනම් ඔයගොල්ලන්ට සුබ පතමින් අපේ වීඩියෝ සෙට් එක ඔයගොල්ලන්ට එහෙනම් අපි නවත්තමු. එහෙනම් good luck guys, all the best.